So a manometer, what is a simple manometer? A manometer is a device. Barometer is used to find the pressure of atmosphere, and manometer is used to find pressure of the gas in the container. So if we want to find the atmospheric pressure, we use a mercury barometer. And if you want to find the gas pressure, the pressure of the gas inside a container or a flask or a vessel, we use the manometer. And this is also called a manometer, or you can also say a U-shaped manometer. What it consists of, a U-shaped manometer consists of a U-shaped tube which is open from one end and connected to a gas at other. So how it works, like example, here we have a gas jar. So there is a jar or a gas jar, and other side it is open, and it is filled with a liquid. The liquid here can be a mercury, it can be alcohol, it can be even water. Water can be used, mercury can be used, or even alcohol can also be used. So any liquid can be used here, but for a barometer it is specifically mercury. Why we don't use water or alcohol? Because it can evaporate. That's why we don't use in a barometer water or alcohol. But here it can be water, it can be mercury, it can be alcohol. So this is a U-shaped manometer. So there's a gas inside the jar. How we can use this device to measure the pressure? So actually there are three pressures. So there are three pressures. Number one, there's a pressure of the gas from the left hand side. The gas is exerting pressure from the left hand side. Number two, because this side is open. So if this side is open, what is there? There is an atmosphere, air is present. So because of this atmosphere, there is a pressure of atmosphere from the right hand side. And because of the difference in the level of the liquid, there's a difference in the liquid level, because one side the liquid is below, means liquid level is lower than the other side. So there is a pressure of the liquid from the right hand side. So we can say there's an atmospheric pressure, pressure of atmosphere, I'm writing PA. There's a pressure of the liquid from the right hand side, and there's a pressure of the gas from the left hand side. If the mercury or alcohol or water stop at this point, so if it does not move, it stop. So what we can say pressure of the gas is equals to pressure of atmosphere plus pressure of the liquid. Is it clear? This equation, how I form this equation? Because on the left hand side, there is a gas inside the jar, and this gas is exerting pressure from the left hand side. So from the left hand side, there is a pressure from the gas. From the right hand side, It is open completely to the atmosphere. So atmosphere air particles are hitting also. So these air particles is exerting pressure on the water surface or a liquid surface. It can be mercury or alcohol. And there is also, due to the difference in the level of the liquid is also applying a pressure from the right hand side. So we can say the pressure from the left, if the mercury or water or alcohol stop between the two limbs, so we can say the pressure of the gas is equals to pressure of atmosphere plus pressure of the liquid. Is it clear, this concept? The equation part as well. So when we compare, yeah, how the equation is formed, as you can see, there is a there are the gas particle exerting pressure from the left hand side. There are the air particles which are exerting the downward pressure from the right hand side, as well as there's a liquid, the difference in the level of the liquid, there's also pressure from the liquid. So we can say the pressure from the liquid plus pressure of atmosphere, this total pressure from liquid and atmosphere is equals to pressure of the gas. Or we can also say the gas pressure is more than atmosphere, because gas pressure is the sum of atmosphere and liquid, or gas pressure is higher. So whenever the gas pressure is higher, when we check the level of the manometer, the side where the is connected, the gas container is connected, that level will be below, the liquid level will be lower, and the side where it is open to the atmosphere, that level will be higher. So it shows that the manometer, the gas which is present is in the container is exerting a higher pressure as compared to atmosphere. There is also a second case for using a manometer. It might be in this manner. So when we have example a manometer connected in this manner to a gas container, so example, on the left hand side there's a gas container. So gas is there on the left hand side. These black dots are representing the gas particles, and the red dots are representing the air particles, and it is filled with a liquid. The liquid can be mercury, it can be alcohol, it can be water. What is the effect of using different liquid, that we'll discuss at the last, but first thing is you should understand what is manometer, and then we'll discuss what are the factors which will affect the pressure. So example, when you read the level, it appear to be like this. So in this, and it stops. So the level of the mercury in this time, the level of the liquid in the manometer, it is like this. on the left hand limb, it is higher than on the right hand side. Now again, there are three pressures. What are the three pressures? There is a pressure of the gas from the left hand side. Then due to the difference in the level, there is a pressure of liquid. This time the liquid pressure is from the left hand side, because on the left hand side it is higher. So it means the more pressure of a liquid is there from the left hand side. And there is a pressure of atmosphere from the right hand side. So when we write the equation, this is the pressure of a gas, this is the pressure of liquid, and on the right hand side there is the pressure of atmosphere. So what we can say, what will be the equation? On the left hand side there is a pressure of a gas plus there is a pressure of liquid, and on the right hand side there is a pressure of atmosphere. So if we want the pressure of the liquid, so pressure if we want the pressure of a gas, so pressure of a gas is equals to pressure of atmosphere minus the pressure of liquid. So when the level of the mercury or level of the liquid is higher on the side where we connect a gas, so this shows that the gas pressure is less than atmospheric pressure, or gas is exerting lower pressure than atmospheric pressure. Is it clear? Yeah, in this means that the pressure of the gas is too low, that compared to the atmosphere. That's why the side where the gas container is connected, that is higher as compared to a side where atmosphere is connected. Means the atmosphere is exerting more pressure or higher pressure than the gas. Is it clear to everyone that the second case for a manometer, the equation as well? As you can see, the gas and liquid are exerting pressure on the left to balance the pressure of atmosphere from the right hand side. Or if we need a gas pressure, so the liquid pressure will move other side, so atmosphere minus liquid will be equal to the gas pressure. And the third case, when the levels are same from both sides, in a manometer, so when the levels are same from both sides, like you use a liquid but the liquid level is same, there's no difference in the level. So if the liquid levels are same both sides, what we can say or what we can conclude, we can say in this case that the pressure of the gas is equals to the pressure of atmosphere. So the gas pressure and atmospheric pressure are same if the two levels are same. But if one of the level is higher than the other, like example, if this level is higher, then what we say, will say gas is exerting more pressure. But other side level is higher, then we say the atmosphere is exerting. There is a pressure of the liquid, Abdullah, there is a pressure of liquid, but both side the liquid is applying same pressure. You can see both side the liquid is at the same height. So pressure applied by liquid from the left hand side is matches with the pressure applied by liquid from the right hand side. So liquid pressure does not contribute to anything. It is same from both sides. So how we read this manometer, a device, as you can see on your screen, this is the manometer. So what we can conclude from this manometer the pressure of the gas supply, it is more than atmosphere or less than atmosphere. What about the gas supply pressure? Is it higher above the atmosphere or below the atmosphere? If it is more than atmosphere, we'll say above the atmosphere. Yes, Abdullah Khan, Heather. Only I can see your response, so I want everyone to respond. The chat is only visible to me. So when you check the gas particles, these are the gas particles, and on the right hand side you have air particles. So you can clearly see, because the gas is pushing it harder or exerting more pressure, that's why the level of the liquid from the gas side is lower as compared to a level of the liquid on the atmosphere side. So we can say the pressure of the gas is more than atmospheric pressure. Or we can say the pressure of gas is above the atmosphere. So you can use these two statements, it is above the atmosphere or it is more than atmosphere. Then how we can calculate or how to write the equation? We can say the pressure of the gas, which is on the left hand side, from the left hand side, balances with the pressure of atmosphere and the pressure of the liquid, and so it is equals to pressure of the atmosphere, I'm writing APA, plus pressure of the liquid PL. What is the pressure of atmosphere? Normal atmospheric pressure is 1 atm or 100,000 pascal. So it is 100,000 pascal. You have to memorize this value. For the normal atmospheric pressure, it is 100,000 pascal. We assume it is at sea level. Then what about the pressure of the liquid? The pressure of the liquid is density of the liquid multiplied by gravity multiplied by depth. So pressure of the gas is equals to 100,000 pascal plus density of the liquid. Example, the liquid we are using here is a mercury. So density of the mercury is 13,600. So density is 13,600, gravity is 10. And what about the depth? The depth means the difference in the level of a manometer. So what is the difference in the level? On the left hand side it is lower and on the right hand side it is higher. So the difference in the level, this is starting from 30 and ending at 60. So the difference in the level is 30 millimeter or 0.03 meter. Whenever we substitute, we should always use or substitute in meter. So it is 30 millimeter or 0.03 meter. So it will be 0.03. When we calculate the pressure of the gas, it is 100,000 plus so we always take a difference in the level because the liquid is exerting pressure. Why we are not taking from zero? When you check this part, so why we are not taking it from zero? Why we are taking the difference? Look, the liquid is applying pressure from here, from the left hand side, and the liquid is applying pressure from the right hand side as well. But what is the resultant pressure? What is the result of these two pressure? The result of these two pressure is this side only. Because liquid applying pressure from left, liquid applying pressure from right. So what is the result of these two pressure? The result of these two pressure is only on this side. That's why whenever we are taking a manometer, we don't take the full level, we take the difference in the level of the mercury or a liquid in both container, the difference. So it is starting from 30 and ending at 60. So it is 30 millimeter or 0.03. So when we multiply 13,600 multiplied by 10 multiplied by 0.03, that is equals to 4,080. When we add 100,000, so it will come out the pressure of the gas is equals to 104,080 Pascal. Is it clear this working, the calculation, how we worked out? To everyone, any doubt? Abdullah, Freen, Alia, Basira, Heather, Shazib, Isra? So the difference in the level will give us the pressure of the liquid, and pressure of liquid plus atmosphere will get the final result. Then what is the effect of using a dense liquid, effect of density on a manometer? So what is the effect of density of liquid used in manometer? Like example, we have two identical manometers, we have two same manometers. Which are having a same thickness, but we are using two different liquids inside the manometer. So two manometers are there, example, same size. In one manometer we are using, and we connect the same gas is at same pressure. The pressure of the gas is same. So both containers have the identical gas. The first one, the liquid which we are using, that is mercury. And the second one, we are using a low density liquid, example, alcohol is there. Density of a mercury is 13,600 kilogram per meter cube. Density of alcohol, different alcohols have different densities, example, this is 800 kilogram per meter cube, which is low density. So what will be the effect of using a dense liquid? So if you are using a dense liquid, because dense liquid are difficult to move, so the difference in the level will be smaller. But if you use a low density liquid in a container, we are using a low density liquid. So what we'll observe? We'll observe that because low density liquid, easy to push, easy to exert pressure, move easily. That's why the difference in the level will be higher. So if you are using a mercury, this height difference will be smaller. If you are using a low density liquid such as alcohol or water, the difference in the level will be higher. Is it clear? The concept that what is the effect of using type of a liquid in a manometer. If it is a dense liquid, then the difference will be lower, the difference in the liquid level. And if it is low density liquid, the difference in the level will be, it will be higher. The final answer will be same, the final result will be same, but the height levels are different. Because what happened when you are calculating a pressure of the mercury, it is dense. When you are calculating a pressure of the liquid, that is density into gravity into depth. So mercury is having a greater depth, but it will have a smaller, mercury is having a greater density, but will have a smaller height. When you work out for alcohol, alcohol density is lower, but the depth, the height level will be higher. So when you multiply them, the final resultant pressure, the final pressure of the liquid will be same, but the depths will be different. Here density is higher, depth is smaller, but here density is lower and depth is higher. So result, the multiplication, the final answer will be same by both liquids. But when we are using a denser liquid, the difference in the level is smaller as compared to when we use a low density liquid. Is it clear? What is the effect of density on the depth? Then there is also another thing, the size of a manometer. The size of manometer also affect the result. Like example, if we use a wider manometer, which is having more greater area, and we use a narrow manometer, and we are using the same liquid. So liquid does not change. We are using the same liquid. Like example, here we are using alcohol. Here also we are using alcohol. So the liquid which we are using is not changed. The gas is in the container that we are using, that is also the same identical gas is there. So the gas container is same, but here we are using a wider manometer, and the other case we are using a narrow manometer. So what will be the difference here? If we use a wider manometer, then the liquid will not rise too much. In both limbs, the level of the liquid will be lower. And if we use a narrow manometer, then the level of the liquid in both limbs will be higher. But the difference in the level, this H will not change. Like here, if this H, the difference in the level, example, if it is 8 centimeter, this will also be 8 centimeter. The difference in the level, because the difference in the level depends on the type of a liquid and pressure of the gas. So difference in the level will remain same, the only thing what happened, the liquid of the level in both limbs will be higher in narrow manometers. So when we are changing the type of a manometer, the difference in the level will remain same, but in narrow manometer, the level of liquid will be higher in both limbs. So what happened, as you can see, if we use a wider narrow manometer, the level is lower in both limbs. Difference in the height is 8. But when we are using a narrow manometer, the level in the both limbs are higher, but the difference in the level is same. Why the difference in the level is same? Because difference in the level depends on the type of the liquid we use and the pressure of the gas and atmosphere. It does not depend on the size of the manometer. Is it clear, this concept? Any question or doubt related to this part? Is it clear to everyone? Now we'll do some questions related to manometer. Okay. In this one, in question 7, a manometer is used to measure the pressure of a gas supply. As we know, a manometer is a device which is used to find the pressure exerted by the gas or gas present inside a cylinder. Which change give the greater value of H? Greater value of H means like we want a greater difference. We want a greater difference in the level. They're asking for difference. So if we use low density liquid, as we discussed, like if we use mercury, if we use alcohol or water, if density of the liquid used is lower density, then the difference in the level will be, the value of the H, the difference in the level will be higher. That's why A is the right answer. If we use more dense liquid, then the H will decrease. If we use a narrow or a wider tube, just now we discussed that the size of the tube does not, it does not affect the difference in the level, so this H will remain same. Even I use a narrow tube or I use a wider tube, the H will remain same. The only thing what will happen or what will be the difference, if we are using a wider tube, manometer, and we use a narrow tube manometer, so if we are using a wider, the levels in both limbs will be lower, like this level H, but the value of the H, the difference in the level will be same. What does it mean? Like example, this level is lower, on the right hand side is also lower, but when we calculate a difference in the level or value of H, example H is coming out 10 centimeter. So if we use the same for a same gas supply, if we are using a narrow manometer, then the level of the liquid in both limbs will rise. But the difference in the level will not change because that depends on the pressure of the gas. So that will not change. the difference in the level in both lengths will be same. So it will be same as 10 centimeter. So they're asking the difference which give the greater value of H. H means the difference in the level. So the difference in the level depends on the density of the liquid used. If we use more dense liquid, the H will be smaller. If we use less dense liquid, H will be higher. And if we change the size of the tube, H will not change. So it remains same if we are using even a wider or a narrow manometer. Question 9 is a barometer. Which height is used to measure the atmospheric pressure? Basically, we assume the pressure of the atmosphere is equals to pressure of the liquid. So which height we use, A, B, C or D, to measure the pressure exerted by this liquid, which matches with the pressure of atmosphere? So that is C, the difference in the level. That's right. The diagram shows a manometer containing a liquid. The manometer is used to find the difference between the pressure of a gas and atmosphere. So basically, as you can see, the gas is applying more pressure. So pressure of the gas, the right hand side is the pressure of atmosphere and the pressure of liquid. So we can say the pressure of a gas is equals to pressure of atmosphere plus pressure of liquid, or the pressure of gas is equals to pressure of atmosphere plus liquid. So which height is used to get the difference in the pressure or pressure of gas minus pressure of atmosphere? So that is C, correct. A manometer is connected to a gas supply. There is a gas leakage. So gas leakage means the pressure of the gas will decrease. If the pressure of the gas will decrease, what happened to level P and what happened to level Q? The gas pressure exerted by the gas is decreasing. So if gas is exerting less pressure, the P will rise. So there will be level will increase and the level Q will decrease. Is it clear? So this is about the manometer. So almost this part is done about the pressure. In the next session, we'll discuss how hydraulic brakes, hydraulic lifts work. Any question related to the class? So the next session, we will discuss the hydraulic brakes and hydraulic lifts. So I'll end the session and share this recording with you.